Now in this particular complex analysis, we'll be looking at the basics of complex numbers. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now to understand the complex analysis properly, you have to understand the number tree. Numbers are divided into many forms. Okay, you have to understand each and every number, what they are called. Okay, I'll be starting from the bottom. It's nothing but natural numbers. What is a natural number? Natural number is nothing but 1, 2, 3, so on to infinity. Okay, then 0 is nothing but a 0. Whole number is nothing but 0, 1, 2, so on to infinity. Okay, you have to remember this one. When the number starts with 1, then it's a natural number. Whole number is nothing but when it starts with 0. Okay, negative numbers. Negative numbers are nothing but -1, -2, -3, so all till infinity. Okay, integers. Integers are nothing but both negative numbers and whole numbers. So it has both positive, negative and 0. Then it's an integer. Fraction. Fraction is nothing but it is divided into three forms: proper, improper and mixed fraction. Proper fraction is nothing but when numerator will be less than denominator, like 3 by 7 or 5 by 13, so on. Okay, improper fraction is nothing but when the numerator is greater than denominator, like if you have 7 by 3, or if you consider something like 51 by 20. Okay, it's an improper fraction. Mixed fraction is nothing but like 1 by 7, or you can write this one as nothing but 3, 2 by 7. Such fractions are called as mixed fractions. Now rational numbers are nothing but integers and fractions comes under rational numbers. Irrational numbers. Irrational numbers are nothing but like pi. We know that pi is nothing but 22 by 7, but there is no exact value for it, right? And e value. Such fractions are called as irrational numbers. Real numbers are nothing but rational and irrational numbers comes under real numbers. Imaginary numbers. Imaginary numbers are nothing but when you have something like root of -4, right? Then we can write this one as nothing but 2 root -1. Then it is equal to nothing but 2i, where I is called as a complex. Okay, I is called as a complex number. Okay, or it will be present as 2j also, I of j. Okay, sometimes you will be having some numbers like 3 plus 2j or -1 minus j. Such numbers are called as complex numbers. Now real and imaginary numbers are nothing but numbers. Okay, this one you have to understand to better understand the complex analysis. Now coming to basics of complex number. Okay, a complex number is a number that can be expressed in the form of x plus iy. Okay, x and y are nothing but real numbers and I is nothing but root -1. Okay, this is a basic thing you have to remember. And basic note point you have to remember is nothing but if z is equal to x plus iy, then x is nothing but a real part of z and y is nothing but imaginary part of z. Then we can write z is equal to nothing but real part of an z plus I into imaginary part of an z. Okay, then one more thing you have to remember is nothing but I square is equal to -1, I cube is equal to -I, I power 4 is 1, I power -1 is equal to -I. It's a basic thing you have to remember. Okay, in a lot of problems you'll be getting this type of values. Now I can be present in the form of j also. Okay, it can be presented I or j also. Okay, now coming to the basics of complex analysis. Okay, if you consider matrix Z is equal to x plus iy. Okay, then modulus of z is equal to under root of x square plus y square. The second one, z bar is nothing but complex conjugate is equal to x minus iy. When we changing the I value from plus to minus or minus to plus is called as a complex conjugate. Our next one, z into z bar is equal to modulus of z whole square. As we know the general formula that a plus b multiplied with an a minus b is equal to a square minus b square, right? Now similarly x plus iy multiplied with an x minus iy is equal to x square minus I square y square. I square is minus 1. So minus 1 minus it becomes plus. So it is equal to x square plus y square. Right? Which is equal to nothing but z modulus whole square. Right? Same thing has been written here. Now come to next one. E power I theta is equal to cos theta plus I sin theta. That's very important. You have to remember this one. Come next one. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. Then let z1 is equal to x1 plus or minus I y1 and z2 is equal to x2 plus or minus I y2. Then z1 plus or minus z2 is equal to x1 plus or minus x2 plus I y1 plus or minus y2. Okay. Now go next one. X minus iy into x plus iy is equal to x square plus y square. You've seen just now. Now come to the next one. The one, modulus of an I is equal to I. Yes or no? If you consider this one as 0 plus I, and you find the modulus of it, which is equal to nothing but under root of 0 square plus I square, which is equal to nothing but root of an I square, right? Root and a square get cancelled, which is equal to nothing but I. Okay. Now go to the next one. I is equal to nothing but cos pi by 2 plus I sin pi by 2, which is equal to e power I pi by 2. Okay. That's very important. You have to remember what is the I value. Now coming to trigonometric polar form of a complex number. Okay. If you have something like z is equal to x plus iy, which is called r e power I theta, which is called r cos theta plus I sin theta, is called a principal polar form of a z. Okay. If you have something like x plus iy, we can present in the form of r e power I theta or r cos theta plus I sin theta, where r is nothing but a modulus of a z, which is equal to root x square plus y square. And coming to theta. Theta is equal to nothing but tan inverse of y by x, which is equal to tan inverse of imaginary part by real part. And it is called as an argument of z, and it is denoted by arg of an z. And theta will be lying between minus pi to pi. Now if you consider a graph here, this is nothing but an x-axis. This is an real part, right? And this is an y-axis. It is an imaginary part. Okay. And here if you have a point x comma y, okay, then theta is nothing but an angle made by it. Okay, from this point to the x-axis is called as a theta. And the point from origin to this particular point, okay, if you consider this particular point as a p, okay, to this particular point p is called as a radius, okay, which is equal to nothing but modulus of z. And theta is equal to nothing but tan inverse of imaginary by real, which is equal to y by x. Okay. Now coming to a few more important basics of complex analysis. The first one is nothing but argument of z1 into z2 is equal to argument of z1 plus argument of z2. And argument of z1 by z2 is equal to argument of z1 minus argument of z2. It's saying that when you multiply two complex numbers, okay, then the angles will be get added. When you divide two complex numbers, then the angle will be subtracted. Okay. Coming next one. As we know that z is equal to x plus y, it can represent in the polar form as r into cos theta plus 2k pi plus I sin theta plus 2k pi. As we know that if you consider cos, okay, theta and cos of theta plus 2k pi, okay. If you consider that theta is equal to 0, then we know that cos 0 is equal to nothing but cos of 2 pi, right? When you make k is equal to nothing but 1. So to represent in a multiple form, we can add it with a 2k pi also. Come next one. Z power n is equal to r e power I theta whole power n, which is equal to r power n cos theta plus I sin theta whole power n, which is equal to r power n cos n theta plus I sin n theta. Now this is being used to find the roots of any complex numbers. Okay, coming next one. When you have a log, it's nothing but no ln, it is at base e, and z, it is nothing but log of x plus I pi, which is equal to ln of r into e power I theta plus 2k pi. You can write this one in the form of log of r plus I theta plus 2k pi. As we know that here there is an e power, so we know that ln of e power 1 is equal to nothing but 1, where ln is in a base e only. E and e get cancelled and e gets nothing but 1, right? So here it has been cancelled and we get an I into theta plus 2k pi directly here, and we know that ln of a into b is equal to a plus ln of n b, right? When you multiply both of them, it is nothing but addition of both of them, right? The same thing has been written here. Now it is nothing but a multi-valued function for k is equal to plus or minus 1, plus or minus 2, plus or minus 3, or 0, or so on. Okay, coming next one. If you consider modulus of z minus e is equal to r, then it is an equation of a circle having a center at an a and a radius of an r. It's nothing but if you consider x and y axis. Okay, then we will be getting a point E, which is nothing but a center of a circle. Okay, and we have a circle here, and this particular radius is given as an r. The same thing has been written here. So now we have seen the basics of a complex analysis numbers. Okay, now we'll be solving few problems for better understanding. Now the question is z is equal to 2 minus 3i by minus 5 plus I can be expressed as. Okay, now we'll be solving this particular function to get a value. Okay, now they are given that z is equal to 2 minus 3i by minus 5 plus I. Now what you do is nothing but multiply both the sides with an minus 5 minus I by minus 5 minus I, right? So which is equal to nothing but becomes minus 10, and this is minus 2i, and this is plus 15i, right? Again minus minus, again it becomes nothing but a minus 3, right? So divided by, it becomes minus 5 whole square, right? A plus b and a minus b, just multiplying it, minus I square, right? So which is equal to nothing but becomes minus 13 plus 13i by, it is 25 plus 1. If you consider 13 common, so it becomes 13 by 26 into minus 1 plus I, right? So it is 1 sir, it goes by 2 sir, which is equal to nothing but 0.5 into minus 1 plus I, right? So which is equal to nothing but minus 0.5 plus 0.5 I, right? Just we are removing the denominator, so it will be matching with the option B. Now coming to one more question of a complex number. The question is given root 3 minus I whole power minus 6 is how much, right? So let us consider z is equal to x plus I y, which is equal to nothing but root 3 minus I, right? So we get x is equal to nothing but root 3 and y is equal to nothing but minus 1, right? Now the general thing that we know is nothing but z power n is equal to x plus iy whole power n, which is equal to r into e power I theta whole power n, which is equal to r power n into cos of n theta plus I sin n theta, right? This is a general formula of it, right? Now they are given to find the value of a power of minus 6. So we get n is equal to nothing but minus 6, right? What is the r? R is nothing but modulus of an z, which is equal to root of x square plus y square. So which is equal to nothing but, we know the x and y values, root 3 square plus minus 1 square. So it becomes nothing but root 4, which is equal to 2. So we got the value of n, it is 2. N is nothing but minus 6 into cos of n is minus 6. Theta is nothing but, we know that tan theta is equal to y by x. So theta is equal to nothing but tan inverse of y by x, right? So which is equal to nothing but tan inverse of y is minus 1 by root 3, right? So tan theta, so theta values becomes nothing but, it becomes 150 degrees, which is equal to nothing but, it becomes 5 pi by 6, right? So into 5 pi by 6 plus I into sine minus x into 5 pi by 6, right? Now here 6 get cancelled, 6 get cancelled, right? So which is equal to nothing but 2 pi minus 6 is nothing but 1 by 64 into cos of minus 5 pi plus I sine minus 5 pi, right? So this is nothing but 0 and this is nothing but minus 1. So which is equal to minus 1 by 64, right? So we got the value of root 3 minus I power minus 6 is minus 1 by 64. Next question. The question is, if z1 is equal to 5 plus 5 root 3I and z2 is equal to 2 by root 3 plus 2I, then the argument of z1 by z2 is, okay. Now they are asking for the argument of z1 by z2, right, which is equal to nothing but argument of z1 minus argument of z2, right? So defining the argument of z1 and z2. Now coming to argument of z1, which is equal to nothing but theta is equal to tan inverse of z1 variables, right? If you consider this one as x1, this is an y1, so it becomes y by x, so it becomes 5 root 3 by 5. 5 get cancelled, so tan inverse of root 3 is nothing but 60 degrees, right? So which is equal to nothing but 60 minus argument of z2, which is equal to nothing but, it becomes theta is equal to tan inverse of y by x, right? So if you consider this as y2, this is x2, so it becomes 2 by root 3, right? So which is equal to nothing but tan inverse of root 3, which is equal to again 60 degrees, so minus 60, which is equal to nothing but 0. So argument of z1 by z2 is equal to 0. Answer is 0. Looking at the nth root of a complex number, okay. If you have z is equal to x plus iy, okay, then the nth root of z, that is nothing but n root z, right? Now the steps to follow to find the nth root is nothing but step 1, write z is equal to x plus y in a polar form. It is nothing but z is equal to r into cos theta plus 2k pi plus I sin theta plus 2k pi. Then we get z bar 1 by n is equal to r bar 1 by n into cos of theta plus 2k pi by n plus I sin theta plus 2k pi by n. Okay, by this method we define the nth root of a complex number. Let us solve one of the example of it. Now come to the question. The question is square root of minus I, where I is equal to root minus 1. Okay, now you have to find the value of minus I power 1 by 2. Right, it is on the square root. If you consider this one as z power 1 by 2. Okay, now if you consider z is equal to say x plus iy, then we can write in the form of 0 plus minus 1 into I, right? So z is equal to nothing but it becomes minus I. Yes or no? So if you consider x is equal to nothing but 0 and y is equal to nothing but minus 1, then you get z is equal to minus I. Then square root of 1 is z is equal to square root of minus I, right? Now the general formula that we know to find the z bar 1 by n is equal to r bar 1 by n into cos of theta plus 2k pi by n plus I sin theta plus 2k pi by n as a general formula to find the nth root of a complex, right? So what is the value of r here? We know that r is equal to root of x square plus y square, which is equal to, it becomes root of 0 plus 1, which is equal to 1. So we got an r value 1. 1 by n. So n value here at 2, right? So n is equal to 2. So it becomes 1 by 2 into, it is a cos of theta, right? We know that theta is equal to nothing but tan inverse of y by x, right? So which is equal to nothing but tan inverse of y is minus 1 by 0, right? So which is equal to nothing but tan of minus infinity, which is equal to nothing but minus pi by 2, right? So it becomes minus pi by 2 plus 2k pi by whole divided by n, 2 plus I sin of, that is minus pi by 2 plus 2k pi by 2, right? Now we'll be solving this one. We get as nothing but cos of minus pi by 4 plus, here 2 to get cancelled, so it becomes k pi plus I sin of, it becomes minus pi by 4 plus k pi, right? If you consider k is equal to 0 and 1, if you consider k is 0, then we get cos of minus pi by 4 plus I sin of minus pi by 4, right? When we get k is equal to 0, now k is equal to 1, then becomes cos of, it's a minus pi by 4 and it's a pi, so it becomes 3 pi by 4 plus I sin of 3 pi by 4. It's a value when k is equal to 1, right? So these two are the square roots of minus I. So it will be matching with the option B. So answer is B. In complex analysis, we have till now seen the basics of complex numbers. In next session, we will looking at below videos on complex analytic function, Mills-Thomas method to find an analytic function on it, then analytic function in polar form, shortcut method to find analytic function, complex line integral, singularities, zeros and poles and immovable singularities, Taylor series, Lorentz series, residue, Cauchy residue theorem, complex integration, Cauchy integration theorem, then ML inequality. We'll be proving it and we'll be looking at one of the example of it. Okay.